Hit the ground running. Been lecturing since last night, man. Okay, so we have, guys, a delta-delta transformers commonly used in certain applications. And we need to find this delta-delta transformer, like we said yesterday. It's banked. So let me just draw, like we did yesterday, how we bank a 3 single-phase transformers to get you. You don't have to do that as a designer, but it's really nice if you know how the system is put together. So what we're going to be doing, guys, is 3 single-phase transformers banked together to give us a three-phase system. Here's what I'm going to do, guys. This transformer is 150 kVA. This is 100 kVNA. This is also 100 kVNA. And I don't know about you guys, but when you were with Mr. Ryman and also with Chad Curdy, you know that transformers have the high side, and the low side. Have the high side and the low side. And yesterday we showed you guys how we put the high side is H1 and H2. You don't need to know that. And the low side is X1 and X2. Okay, so if I want to connect these in delta, you're not required to connect this in delta. It's good if you know. If you want to connect these guys in delta, I don't know if you know, you can maybe use a different color here. Just so you grab these, you tie them together. You grab these and you tie them together, and you grab these and you tie them all the way together. This is a delta. This is a delta on the primary side. If you guys want the delta on the secondary side, you grab the same thing here. You grab these, you tie them together. You grab these and you tie these together. And you grab these, there you go, and you tie them all the way together. So that's how we connect a delta. We series all the coils. Look how easy that. Series all the coils. We series all the coils. All the coils are series, as you guys can see. And then delta. Everybody knows that's very easy. Series the coils. Can you guys see how it's series? The coils are series. And then, again, you don't need to know that. I'm just explaining this one to understand the problem that we are having. Hold on, sis, we're not done. So this is how you physically, mechanically connect that baby. And the top is the schematics for it. The same connection. And then we bring we need to bring the phases. So Brad, we bring from every 2 connection, from every wire right here. Use a different color here. Why is it okay, black. From every connection right here, I'm going to grab a phase. From every 2 connections, I grab a phase. From between every 2 connections, I grab a phase. Okay? So this is, I want to call this is phase A, and this one is phase B, and this one is phase C. Okay? As a matter of fact, like to you, the way I want it, this will be a phase B, and this is phase C. This is how you connect the secondary as a delta. The primary as a delta, guys, piece of cake too. The primary as a delta, also piece of cake. I'm going to use a green. Should we use a green? Let's use a green. No, I want to use a green for other colors. So for let's use blue on that one. So here you go. You grab from here 1 connection. I'm going to call this one and another connection from here. These are across this one. This is my phase A, and this is my phase B. And one from right in here, that will be my phase B. And that baby here, will be my phase C. Okay. Again, I can't emphasize, you don't need to know this connection. It would make you a better designer if you understand how it's connected. Okay. So it's phase ABC on the primary, ABC on the secondary. We have 3 transformers. We bank the 3 transformers together, guys, to give us 3-phase system. Okay. Everything that I drew here is not on the test. It's just for you to understand. Our problem have not started yet. This is how they connect them, guys. Now I want to center. Can you see that, Brad? How is this a center tab? They took the guts of 1 transformer. So this is where you take. I didn't show that one here. So what they do, guys, very easy. They take 1 wire from this transformer here, and they grab it all the way here. That would be my neutral. And every neutral, what do you guys think for the neutral has to do? Has to be grounded. So they take ground one wire right in here, the green. They take the guts of the transformer, right? You can see it right here, easier. And they bring it to the ground and they establish their neutral. Everybody can see what I did here? This one is at that point right in here, right in the middle of a transformer, they ground it. Okay, any question guys about the connection? So what do we need to do? We need to find, my friends, a few things about this transformer like we did yesterday, Spencer. A few things for this transformer. Any question about the transformer? 100, 150, 100. The voltages, yeah, you're going to ask me, Chad, what is the voltages? The voltages, guys, we're going to be using for this system. Let's use a 2400 volt on the primary. On the secondary, we're going to be using the commonly used 240/120 volt. We're using a 240/120 volt on the secondary side, 2400 on the primary side. 2400 on the primary side. Any question, guys? Any question about that? Where would you use a system like this one, guys? In a place where 90% of your loads are three-phase and only 10% of your loads are single-phase, they use a system like this. Lift station, well houses. And again, I know we covered some of this stuff, guys, before. As I said yesterday, for those of you who are here, this is warming up into using the transformers and the panels and so forth. Any question, my friends? Any question? Let's do the impedance of this transformer. The impedance of this transformer, I'm going to make it this time 3%. The impedance of this transformer, 3%. And the impedance of this transformer altogether is 3%. 3% impedance. 3% impedance. Okay. Any question, guys, about the given? Any question about the given? Any question about the given? Before we go ahead and start finding information about this transformer. Any question? Can I move to the next slide? No questions? You good? Okay. All right, moving on to the second one. Am I going too fast, guys? Too fast, too slow? Too fast? Did you say too fast? No? Good? Okay. I can wait. Good? Huh? How long? Are you good? Are you good?
Yeah, good.
You're good? Okay. All right, number one. Number one, guys, is what I want you to find is the kVA of the system. kVA band. Now for the kVA band, guys, this time we have two kVAs. We have two kVAs. We have a three-phase kVA and a single-phase kVA. I want you guys to look at this system. There is a single-phase kVA for this system and three-phase kVA. The three-phase kVA is basically the contribution of every transformer at 100 kVA level. So if I want this system to pump kVA three-phase, I want this one to pump 100, and I want this one to pump 100, and this one pump 100. That will be the 300 will be the the kVA contribution of three-phase kVA. Why? If you want three-phase, guys, out of this transformer at 150, can this transformer pump 150 kVA? Can't. Doesn't have it. So for three-phase contribution, we need to find 100 kVA of each one of these transformers. Why 100? Because that's as much as two transformers can give. They can't give more than 100 kVA. This guy can give more, but these are capped to 100, so I have to cap this one to 100. So when we do the kVA, guys, we're going to do two types of banked kVAs. Number one is we're going to call it three-phase kVA. This one will be 300 from the first one, plus 300 from the second one, plus 300 from the third one. Well, 100. 300 from the first one. So it's going to be 100 from the first one, plus 100 from the second one, plus 100 from the third one, for a total of 300. Thank you. 300 kVA. So that's my three-phase kVA.
Excuse me.
Yes, sir.
Why do you have then 150 here in the middle?
Mr. Bear, because to give a three-phase, each transformer has to give the same amount of kVA.
But in the middle we have 150.
Yeah.
Now
The transformer number, transformer number 1 and 3 can give only 100 kVA. So the one in the middle cannot give more than 100. So what you're asking me, what happened to the other 50? What happened to the other 50? The other 50 guys will be consumed by the low volt, by the line to neutral, the single phase. So the single phase kVA of the system. What's the single phase kVA of the system, guys?
150.
Thank you. How do you find this one? You take the 100K minus 100K, and that will get you what? 50 kVA. That's all what you have to do. 50 kVA. 50 kVA. 50 kVA. Any question, guys? So that's the only thing different from what we did, guys, yesterday, as we have two banked kVAs, one three-phase and one single phase. So if I ask you, Ryan, my friend, can you use single phase more than 50? Your answer should be no. I can't use single phase more than 50. Can I use three-phase more than 300 altogether? No. So they cap the three-phase. So what does that mean, guys? Ben, my friend, when you add all your three-phase equipment, keep add. When you hit the 300, you stop, three-phase. Then you go to the single-phase equipment. You add your single-phase equipment, guys. Add. When you hit the 50, you stop. Yes, sir.
So for the load of the system on secondary, for not using the center pole, so the three-phase will be up to 240 volt three-phase.
Yes. Yep. All the loads will be three-phase 240, and
120 will be
the 120 will be the single-phase. Okay. Good point. Okay, so that's the first thing I want guys to mention about that particular one. The most important thing, guys, here is sizing four things like we did yesterday. Everything that I want to do is mental exercise. This is really just to understand the system. We're going to find the voltages and so forth, mental exercise. Four things you need to know. How to size the conductor and the overcome protection device. The conductors and overcome protection device. Any question about this? I want you guys to keep this in mind as we go through. Can I move? May I move?
Yep.
Good. Okay, number two, my friends, if you guys remember what we did yesterday too, we said voltage V primary line. What is the voltage primary? The primary line voltage. That's 2400, piece of cake, Chad, 2400 volt. No problem. Number three, so that was, we did voltage primary line. Voltage primary coil. Voltage primary coil. What was the voltage primary coil? It's a delta. It's the same, 2400. See, these are easy to fill, so I'm going to cruise through them. Let's go to the fourth. So, voltage secondary line. Voltage secondary line. What's the voltage secondary line? Line to line voltage, guys. 240, right? 240 volt. No problem. And voltage number 5 is voltage secondary coil or phase. That one is also 240 volt, guys, but also they have a 120 volt coil. So two voltages, because we have two voltages in the coil side. We have a 240, right, like a delta, and also don't forget that we have also 240 120 volt, a 240 120 volt. Huh?
It's the 120 coming from on that.
From the center tab. The 1 is coming from the center tab. Any question, guys? So I went fast through that one. Anybody? That's straightforward. It's the delta. Just writing the information about it. The voltage line and coil. Okay. Any question up to this point? All these is just picking information, mental exercise to help you understand the system.
What's the KVA
Which KVA?
of the transformer?
The transformer KVA, we found it. We see the transformer, three-phase KVA of the transformer would be this, and a single phase would be 150, right? Okay, so now let's go to any question guys about these. This is just picking information. Yes, sir.
Yeah, so the one where you found the single phase KVA, when you used the 100, what if there was three different?
Give me a scenario.
Well,
Like
if
you
there
say-
was A bank that was 75 KVA, one was 100, one was 150.
You would never do that. You would never do that. Here's how we bank him, and I'll tell you why. Very good point. What if that was 75, this was 150, and this was 100? You would never do that, guys. It's always two transformers will be the same, and the third one will be bigger. And you know why, Eric, this one is bigger, right? Because that's the guy's going to see the single phase. So they always put them, two transformers, the same size, and the third one bigger. And the biggest one is always the one has a neutral. Always. That's the reason why we have this banking.
And just subtract one of the smaller ones.
Yeah, absolutely. I guess you can do that, but it's like, say your scenario, 75, 150, and this is 100, then all the three phase will be limited to 75, 75, 75. You didn't gain anything. You did not gain much. So they always, guys, two transformers are the same. The third one is larger, and the largest one is always the one that has the neutral on it. Always.
And they always be in that order.
It always will be in that order. And always the B guys will be here, because remember that wild leg? The wild leg, the orange leg, that's the B. Phase to neutral is going to be 208. That's where the phase to neutral. See how in my case here, I actually, thank you for bringing this to my attention. This should be C here. And can you guys change that one, please? And this one should be B. Anybody knows why, guys? Because that's always the B is the wild leg. A wild leg is from here to here, the voltage is always 208. The one that you're not supposed to use. The one that you're not supposed to use. So it's always A and C are across this baby here. A and C. Any question guys about this? So moving on to number 5. Is collecting information. Number 6. Number 6, guys. Number 6, my friends, is we need to find I primary line. I primary line. The only thing we're going to add for I primary line, for the I primary line, guys, we're going to add two things. I primary line 3-phase. I'm going to write next to it 3-phase. Okay? Can you guys add the word I primary line 3-phase? I'm adding I primary line 3-phase because there's line coming from the 3-phase and line coming from a single phase. I primary line 3-phase. This is piece of cake. What was the KVA of the transformer 3-phase? Divide by what's the voltage on the I primary line 3-phase? What's the voltage on the I primary line 3-phase? Okay, so what's the voltage, guys, on the secondary on the primary side? 1.73 times 2400. 2400. So I primary 3-phase. I came up with 72.3. Anybody came up with something different? 72.3 amps. 72.3 amps. Okay, so that's the first calculation that you need to do. I primary line. Then I primary line single phase. I primary line, guys, single phase. I primary line single phase. Okay? This is piece of cake. You're going to take, what was the single phase KVA? 50 divided by what's the voltage? 2400. Now, Brooks, my friend, do I multiply this one by 1.73? No, it's a single phase. So if you do that, you're going to find I single phase 21 amps. 21 amps. 21 amps. 21 amps. Okay? 21 amps. Any question, guys, about this? Any question about this? So we found the I line. Now, one thing I want to add here, my friends, for this particular one, so since we have two currents, this is how it's going to go. Phase, let me tell you what, let's go by phase A and C. For phase A and C, what do you guys think phase A and C are going to see? Look at this. Let's go back to the picture here. Phase A and C, they're going to be seeing the, can you guys see phase A and C on the secondary side? The same thing on the primary side. Phase A and C will be seeing the current that's coming out of the three-phase as well as the current that's coming out of the single phase. So we add them up. Phase B, look at phase B here. Phase B will only be seeing the current that's coming out of the three-phase. The current that's coming out of the three-phase. Did you guys hear me? Phase A and C, they will see the current that's coming on the primary and the secondary and the primary. Will be able to see both the AC, the single phase and three phase. Phase B will only be able to see the single phase. That's the only difference for this transformer. What does that mean, Chad? If you come over here, for phase A and B, then the current guys, you just add them up. So you have I'm going to say phase A and C current, which is line current. You're going to add 72.3 plus 21. That will give me 93.4 amps. Done. The last one as phase B. What do you guys, phase B current? What do you guys think phase B current is going to see? Phase B current. What do you guys think phase B current is going to see? Only the three phase. So 72. 72.3 amps. 72.3 amps. 72.3 amps. This is really the only difference between what we did today and what we did yesterday. Everything that we've done yesterday, guys, we're going to do it today. That's the only difference. We have a single phase current and a three phase current. That's the confusing part of it. And if you take it in steps, you find the three phase current. Yesterday we did this step, guys, but that one that wasn't there. So now we recognize that there will be two currents, one coming from three phase, one coming from single phase. Add them up. Only where, Spencer, we add them up with phase A and C. Why phase A and C? Because phase A and C are across the coil or the transformer that has a neutral. Across the transformer that has a neutral. The A and the C. B is not. So that's what B is going to see. So who cares? Now we're going to end up with conductors, guys. Certain phases have conductors bigger than others, and that's okay. See why? Certain conductors carrying more current, so you're going to have three-phase system, but some conductors, two phases are bigger, thicker than the third phase, which is fine because of this. Any question, my friends? Any question? Now, for those of you who were here yesterday, guys, I don't want to do the coil current. I don't want to confuse you with the coil current because the coil current really has no meaningful value for us. So I'm not going to do the coil current. I'm going to jump. So if I'm going to jump, guys, I'm not going to do the coil current. Which, if you take the coil current, by the way, if you will do the coil current, all what you have to do is just divide this one by 3. And add this number to it, but I'm not going to confuse you. Just the line current, because that's how we size. I primary coil. I'm going to go when we did that one. That's all going to be in the delta center tap.
Okay.
Center tap. Delta center tap. So I primary coil, I secondary coil. I'm going to go, guys, directly to I primary line. Let's go directly. So we're done with the. I want you guys to please highlight these two numbers because I'm going to get back to them. These two, I'm going to get back to them to size the conductors. I'm going to get back to these numbers to size the conductors. So let's go, guys, into number 7. Number 7. Number 7, no, we're going to find the I secondary line. I secondary line. Now there is a 3-phase of it. I secondary line equal the 3-phase, guys, equal the same thing. 300 K divided by 1.73 times, what's the voltage on the secondary, my friends? What's my voltage on the secondary?
240.
Thank you, my friend. 240. And if you do the math on this one, if I did it right, it's going to be 723. 723 amps. 723 amps, the secondary line current coming from the 3-phase. Piece of cake, Chad. Then I secondary line single phase. It's going to have this. How much single phase KVA do we have? 50 divided by 240. And if you guys do this one, you're going to find 208. 208 amps. So this is the line current on the secondary side coming from the phase and coming from the 3-phase and from a single phase. From the 3-phase and single phase. Exactly like we did, guys, on the primary side. Exactly like we did on the primary side. Okay. Any question about this? Am I going too fast, too slow?
I guess on the last one, you had 2 different sets of numbers. Can you go back one real quick?
Mm-hmm.
That's all IPL?
That's IPL. Yep. There are 2 IPLs. One for the 3-phase, one for the single phase. This, guys, will see both of them, A and C. B is going to see only one, the 3-phase. What do you guys think? I'm going to repeat this here for the secondary side. I'm going to repeat this for the secondary side. For the secondary side, then, phase A and C current. For phase A and C current, guys, phase C, what do you guys think phase A and C current is going to carry? 723 plus that 208 plus 208. The 2 phases are going to carry 931. 931 amps. So the 2 phases, not together, individually, each one of them will be carrying this amount of current. The contribution goes from a single phase and from a 3-phase. From a single phase and the 3-phase. The last one, and you guys can predict it, phase B. Phase B current. What's phase B current, guys? Phase B current is going to be only 723 amps. Phase B current is only going to be 723 amps. Why 723 amps, guys? Because phase B is only going to see the contribution from the 3-phase. Does that look familiar, guys? We did the same thing on the primary that we did on the secondary. Any question, my friends? Sir Bev? The only thing I'm gonna skip is I don't want to do the line. I don't want to do the coils, guys. I want to skip that one on this particular one, transformer, and I'm gonna go directly into the transformer ratio. Any question about this? I want you to highlight it. Please do me a favor. Highlight this one. Put a star next to it, or an asterisk or something right next to it. Because we're going to come back and pull these numbers to size conductors. We're going to pull these numbers to size conductors. Okay. Any question, my friends? Any question? One thing I want to do, number 8, guys. Number 8 is going to be slightly different, DJ, so don't start yelling at me. I want to find the
It is continuous or no?
It's number 7, so number 8.
Oh, sorry.
Number 8. It might not look like an 8, but we'll make it look like an 8. Number 8. Number 8, guys, I'm going to find transformer ratio. Transformer ratio. What's that?
10 to 1.
The transformer ratio, thank you. The transformer ratio is V primary coil over V secondary coil equal 2400 over 240 equal, thank you my friend, 10, and this will be 10 to 1. Done. This is mental exercise up to this. Now we need to go size the feeders. Let's go size the feeders. That's what you guys are going to be asked to do, sizing the feeders.
No transformation.
We don't want to do the transformation. It's the same, transformation will be the same way. Okay, number 9, I'm going to find primary feeder size. Primary feeder size. Okay, for primary feeder size, guys, I want to split it into 2 for phase A and C. For A and C, what was the amps for A and C when we sized them? For A and C, you guys remember for A and C on the primary side, what was it? 94 for A and C. Together, on the primary side, they were 91.
93.
So 93.4. You're going to take this one to, do you guys remember the table that we went to? Table 310.77 under 90-degree column. We're going to take this is a medium voltage cable, guys. Medium voltage cable. Medium voltage cable. We're going to take it to table 310.77, not 310.16 as we normally do. Under 90-degree column, under 90-degree column. And if you guys go there, how many conductors and what size? How many conductors and what size? If you guys go there, you're going to be 2 conductors. You're going to have 2 conductors, and the size is number 4, and the installation is called medium voltage -90. This is the answer for phase A and phase C. The answer for phase A and phase C. Any question about this, guys? Anybody want to check it on 310.77 under 90-degree column? No, the same. Well, it should be, no, it should 310.15b17 it says in the new book. The new book, this table, I believe 310.15b77. 15b77. Can you check that one? They just add .15b in front of it. 310.60c is that? Okay, thank you. 310.60c.77. 60c. That's 7. Are you guys all using the 2011? So that's 60c. That's 60.60c77. Thank you. We're basing the class, guys, in 2008. So you can change. You're gonna do adjustment on your own. Any question, guys? Any question about how we found it? Now, Ryan, what happened to the third phase now? Third phase is going to be different amps. The third phase is going to be different amps, right? You're going to go.
Is this where we do the options?
Yes, thank you. This is where you're going to do, and I told you that continuous load is already incorporated, and yeah, now you can, if you want to, you can go multiply by 1.25 in size based continuous load. I usually incorporate, Spencer, the continuous load in the size of a transformer when we came up with. So I size directly based on the amps. Good point. Any questions, guys? Why 2 Anybody can wonder why two conductors? Because two phases. Why number 4? Because when you guys went into under that table that we went yesterday, everybody found that number 4? Did they do it right, Eric? Is it number 4? Did you come up with different? Number 4.
No, I
I think we should take 5 now.
Give me 1 second, I'll give you a 5. I'm gonna do the second phase, I'll give you guys 5 minutes. Let me give you just the second phase. Okay? The second one, guys, phase B. Phase B, what was the current for phase B? Thank you, 72 amps. Then you're going to take the 72 amps to table 310.77 under 90-degree column. And you're going to find how many conductors? 1 conductor. And what size?
6.
What size conductor?
6.
Number 6. Is that what you come up with, Mr. Bath? Thank you. Number 6, medium voltage dash 90.
So we're gonna put that, we'd still do that under this one here.
Yes. Yes. So here's your choice, Brooks. Either you go, 2 phases are number 4 and 1 number 6, or you know what? You say, Chad, are you a knucklehead? I'm going to put all of them number 4 and color it.
you have to.
Yes, sir.
Don't know which page to go by here. You want single insulated copper conductor directly buried.
In dots. That's what we chose to go.
Oh, this is what we.
That's why you can use. Yes. Yeah, the 3 of them will be the same. Yeah. Yeah, we're bringing them underground. This is an assumption you have to make, yeah. Why did I pick this one? Because this is the most common one. You can use this one. You can use any one of them based on the assumption, guys, that we're bringing the medium voltage from underground in ducts with a medium voltage cable and no more than 3, right? 3 of them in 1 duct. That's kind of the assumption. And we went under this because, yeah. So that's an assumption. Now, why would I use this one? This is the most common one for medium voltage. Though, if this applies to you, you might have to use this. Why did I use it? 1 circuit. I could go, this is pure parallel. If we're parallel, go 3 circuits, or up to 6 circuits. But we only have 1 circuit. We don't have to worry about it.
Aren't you really paralleling this connector so you have to use the same side?
No, we're not paralleling.
When you run them, no.
When you parallel, yeah, when you parallel conductors, this means you tie them at the end like this. Do we tie phase A and phase B together like this?
No.
Then they're not parallel. They're carrying the power. That's what paralleling of a conductor, guys, means. You tie the conductors at the end. This is you shorting them. Yeah. Now, I can carry. Now, I'm not telling you guys, in a case like this, Camille, my friend, I'm not saying that as an engineer, you would say, you know what, Chad, I'm going to go number 4. Your choice. You can go number 4. Yes, sir.
At this point, on the primary side there.
Yep.
It doesn't matter what side is it. Isn't the utility running that anyway?
Not all the time. What if you have a primary, they call them primary users of power, like a 3M, take the 13.8. U of M take the 13.8. We did a lot of projects. Mayo Clinic used 13.8. So you will be sizing these. Very few of you probably will get into that. Probably 10% of engineering firms deal with medium voltage. Yes, sir.
Some of the notes I've seen on things would be like coordinate with the utility company and provide conduit.
You are absolutely right. That's you just said. That's if the utility bringing the medium voltage. We don't even mess with that. If it's the utility, I'm telling you, utilities give certain customers, big customers, guys, take the 13.8. Take a 160 as a matter of fact. They take 169,000 volt, bring it to the transformer, and then there they take 13.8 and they distribute through the class. So you own the 13.8. If you don't own the 13.8, you don't even mess with this. This is if you own the 13.8, which you could. There's a lot of customers, not a lot, but there are customers who own primary distribution system. Okay, 5 minutes break.
What do you have to have a special, you have to have an engineer go through everything before they get considered that? or-
Yeah, it's engineered project for the most part.
No, I was just wondering if you with clarification thing.
Sorry, I'm so sorry. I really am.
You're just like, without it.
Okay, let's so we size the primary. Let's go size the secondary, guys, if you don't mind. If you listen to your friend Chad, number 9, number 10. Number 10, we're gonna go size. We're gonna call it secondary. Secondary feeder size. If you guys remember the secondary feeder size, if you haven't done that, if you take the secondary feeder size, what was the secondary feeder size for phase? We're going to say phase C and, well, how about if we start A and C instead of C and A? Phase A and C. The current for phase A and C, guys, was 93.1 amps. 931 amps. And if you take this one to 310.16, and Brooks, why did we go to 310.16, my friend? Because it's a low voltage, right? Low voltage cable. Which column and why? Which column and why?
90. It's over 100.
Which column and why? One more time.
75.
75, 90 with the rate. I think you were confused with the rate.
I was set my mind's on it.
75-degree column. And okay, now I don't know about you gentlemen, this is where a moment of truth. If you want to make a continuous load and multiply by 1.25, be my guest, do it. I do it, I add the continuous load as part of calculating the size of a transformer. So I don't multiply by 1.25. I don't know if I want to carry 931 amps, guys. So we're going to parallel. Long story short, we're going to parallel this. So let's parallel 3 sets. How many parallel did this? Yeah, let's parallel 3 sets. So I take 931 divided by 3. Why did I pick up 3? 3 give me close to 300 amps. 300 amps, guys, are good to carry with around 500 kcm. So if you guys divide this, you're going to end up with 110 amps. 310 amps, thank you. And if you take it to 310.16 table with under 75-degree column, yes sir.
What is it now on this one, 310.15B16?
Yep, 310.15 B16. Now the 310.15 Ryan B16 is right, not the .60. You're absolutely right, man. That was meter voltage. Okay, for this one, guys, I came up with, here's how I'm going to write these, guys. I came up with 2 conductors, each one of them, let's write them right here. How about 2 conductors, each one of them as number 350 kc and m. 2 conductors, number 350. Though I want you to say 3 sets of. Can you guys? 3 sets of 2 conductors 350. Does that make sense? Because there's 3 sets with parallel. This is for phase A and C. Let's do phase B and call it a quit here. Phase. This is not close up even to a phase, even in Arabic, man. Phase B. For phase B, my friends, what was the size for phase B? Phase B only saw how much?
720.
723, right?
Yeah.
Thank you. So we have a 723 amps. I'm going to parallel 2, guys. So I'm going to take the 723 amps, divide by 3. If you take this one, 723 amps, divided by 3, you're going to find 241. Where did you get 361? I 271 amps.
That's how you said 241.
241. 241 amps. Thank you. 241 amps. Okay. I want to go to the next page, guys, and then we go size the conductor. 241 will give you 250. Will give you 250. Yeah, that's the difference. 4 aught. Why do I have 4 aught here?
That's at 230 is 4 off.
241 will give you 250?
Yeah.
Okay.
If you're in
No,
the
it's actually
power.
2. You're absolutely right. You're absolutely right, 250. So if you go there, let me just stay back. Sorry. Any question, guys? So we found 241 amps. We're going to go size the conductors based on table 310.16. Yes, sir. We're not done with neutral yet. Just hold your horses. I'm not done with the. Yeah, let me just. Can you hold your horses for the neutral? Just hold your. Yeah, good point. Very good point. Hold your horses for the neutral, guys. Very good point. I will size the neutral in a second. The neutral. So 241.
We can divide by 2 if you want it.
Why would you divide?
Yes, you can. You want to parallel 2 sets.
I mean, instead of 3.
Yes, you can. You can parallel 2 sets. You end up with a bigger conductor. But yes, you can. If you or you can divide it by 4. As long as you can't parallel less than 1 aught.
If you divide 1 by 4, you have to divide the other.
Yes.
You have to do it all. The same.
Thank you. Yeah, I see your point. If you, if I decided to go 3 here, I have to go 3 here because we're parallel. Yep.
Is that 350s? You divide by 310. These conductors.
310 amps.
310
Yep.
amps.
And then
Two,
350.
350.
2 conductors, 350 each, 3 sets.
Is that 350s?
3 350s. In every phase, yes. 3 conductors, 350s in every phase. Let me draw them in a second here, guys. Just give me 1 second here. 41. So if you guys take the 241 amp, take it to 310.16 table, 75-degree column. You're going to end up with 250. Did we say 250? 1 conductor, 250 kcm. So we're going to have 3 sets of 1 conductor, 250 kcm.
Never mind, I just answered my question.
3 sets of 1 conductor for this particular phase. Any question, guys, about this? So basically, we're going to end up with 3 sets, guys. 3 sets. Each set will have 2 conductors, 350, and 1 set and 1 conductor, 250. 1 conductor, 250. The neutral. Now the neutral. Now, is it now? Ryan, my friend, you say, Chad, I want to make them all 350 and call it a day. Be it. But there's a big difference between 250 price. Look at that, 3 sets. See how the price becomes a major factor here, where you don't need to. The major, I can go make them 350 and it's fine, meet the code. But imagine how much you're going to pay 3 sets instead of 250. Now you're going to pay 3 sets 350. That could make or break your big chunk. 250.
Depends on how long you're running this.
Yeah, longs and you're going to add, if you go this, I guarantee you're adding 25% extra on your you go that size jump, at least 25% extra on that particular, the same, all things considered. Okay, so we got this one, guys, my friend. Let's go back to the neutral. I had somebody asking about the neutral. I found somebody asking about the neutral. Now the neutral conductor, which number were we at? Number 10. Number 10, number 11. Neutral conductor. For the neutral conductor, guys, here's what I want to remind you guys, the neutral conductor is on the secondary side is only going to see the neutral current. So what was the neutral current? Or the single phase current? The single phase current was 208. Thank you. It was 208 amps. 208 amps. 208 amps. 208 amps. Okay. Now we're paralleling conductors. We're paralleling conductors, and we have a neutral. So how are you going to guys do that? We're paralleling conductors, and we're going to be doing a neutral. If you parallel the conductors, guys, we have to put the neutral, and the three phases all in one conduit. The neutral and the three phases all in one conduit. So let's say, first of all, we'll go size this one. So if I want to go size a neutral here, since we're paralleling, that's kind of an interesting situation. What, divide this by 3. What do you guys divide this by 3? Let's make it. Divide this by 3. What do you get? 69 amps. Go to 310.16. And since it's a transformer, I know it's a smaller amp, guys, but since it's a transformer and all the lugs are rated for 75, most likely, just size it based on 75 degrees. What do you get? How much? Number 4. I have one little problem, though. Can I parallel this now 1 aught? One little problem. So what do you need to do then? Up it all the way to 1 aught. So here's I need 3 sets of 1 aught. Everybody knows why I went to 3 sets of 1 aught? Because I can't parallel more than 1 aught. I can't parallel. In the code. I'll get you somewhere in the code. 3, you can't parallel less than 1 aught. 310 dot something.
310.h2.
H2? Thank you.
H2.
3 sets. Okay, I'm going to draw the circuit, guys, just because. Here's my circle. 1, 2, 3. 1, 2, 3. Just give you an idea, graphic illustration of what we're doing. Graphic illustration. So I have my phase A, my phase A, my phase A, and then I have my phase B, my phase B, my phase B, and then I have my neutral, my neutral, my neutral, and my neutral coming into this, and the last one I have my phase ABC, my phase C, and my phase C. This is what we were paralleling, right? 3 sets, and just to put the numbers on them so it doesn't confuse us. Let's say A, let's just say this is A, B, and C, and a neutral. So if I want to put numbers on just on one of them, you take the A and the C. You guys remember that? This is going to be what size AC did we say? 350? 350 kcm. And B was what? 250 kcm. And what was N? 1 aught. You can see, and these are typical for the 3 of them. Typical for 3 of them. Now, is there anything wrong, Mr. View, if I said I want to make them all 350 color a day, Chad? No, nothing. Yes, sir.
You know, the whole using different wire size for like 3 phase and everything, right? So understandable, like, you know,
Okay.
so, but in real life situation, how applicable is it to actually fold? I've never did it.
Never did it, but it's because
Have
how
you ever fold?
yeah.
No, I've never.
I never did it. The only one is you drop.
Yeah, drums.
And how many times did you guys wire center tab delta?
Never.
Okay. When you wire center tab delta, center tab delta, guys, are used mostly where 90% of your load as 3 phase and only 10%. Well, a good example would be lift stations where you have multiple pump well houses, multiple pumps, all of them sitting there. All of them are 243 phase, and you need just a couple of lights and receptacles. So take this one as a mental exercise and use it if needed.
No, it's fine. I'm not.
No, I see your point. I see your
I was wondering, like, how often, if you know, you're an electrician, do you ever fold?
I've never wired it.
Okay.
I've seen it. I designed it for lift station. Personally wired it, no.
Can you design it if you just size of conductor down for them.
That was sized by the utility. The stuff that we did, that particular part,
This is
well,
the-
the primary side. The secondary, yes. If you go to a center tab delta, yes, you will find a conductor, the two conductors larger than the other one. If you decide to go that far out, again, there's nothing wrong, guys, with going 350. Don't misunderstand me. There's nothing wrong with going 350.
So it's under the value engineering.
I personally think going 350 on these runs, look at these, how much cover you're going to put. On these runs, value engineering, I would not hesitate putting my stamp on it. Why would you go to 250 when I know you'd never go on certain phases more than 250 amp? Why should you go 350? I mean, there's nothing, by design. And if you did, you burned your transformer. You shouldn't. If you did, then your system is designed, If you start with the KVA, this is how we start. We start with the KVA, then add future expansion. Remember, that's how a good engineer comes. Start with all the KVA of the loads. Keep add. Here's the single phase. Here's the three phase. Keep adding them. When I have this chunk, now future expansion, 15%, say, add 15% future expansion. I accommodated for future expansion. Then I came up with these sizes of the transformers, 150, 100, and 100. That's after you did all this is what the engineering value happens, right at the bottom, before you come to the size of a transformer. Now size of a transformers is taken into consideration future expansion and value engineering. Then why should I expand again? Why should I? So it's opinion.
Okay, so
For the test, please do it this way.
you got two 350s on A and C, and then 250 on B.
Yep. 250 on B and A and C 350, and the neutral is 1 aught. I'm not going to confuse you. I could do it differently slightly and make a smaller neutral. If you pull all your neutral in one conduit, all your phase A in one conduit, all your phase B in one conduit, all your phase C in one conduit, that's okay if they're PVC only. And you're coming from the bottom, no holes. If you do that, you can come up with a much smaller neutral size. Not commonly used, but that's another way of reducing your. Yes, sir.
The electrician standing in the shop and he has pictures of, I think it was like 13 sets parallel and it was like 7 different conduits or whatever. And there was all A, B, and C phases within separate conduits, and then there was one conduit that just had A, B, and C neutral.
So all the neutrals in one conduit.
All in PVC.
Yeah, you can do that.
Can't do that.
Yeah, you can.
You can, but
Ye-
you can't do the metal conduit.
No metal. Did you say steel metal?
They're all PVC.
PVC. Yeah, that's okay. You can do that. Then if you rearrange them this way, you can come up with smaller size conductor neutral conductor. Any question, guys? So hopefully, why do I do this to you guys? Because hopefully we're creating designers. Yeah, so hopefully we'll take this idea when you design project, guys, and you become your own project.
You can get crazy.
You'll get crazy. Okay, let's do that. We're gonna size the fuses before I let you guys disappear here. Let's go size the fuses for me, please. We're gonna size the fuses because that's the second thing we do. So where are we? Which number are we in? We're at number 11, number 12. Oops, number 12 fuses. Number 12. Primary over current protection device, and I decided DJ to use fuse single-handedly. The same thing, guys. We're going to go for phase A and C. So you can see how it keeps repeating itself, phase A and phase C, phase A and phase C. So for phase A and phase C, my friends, I have 9 on the primary sides. Secondary, I need to see primary fuses, phase A and C. This is 94. 90, was it 93.4 or when I have 94? So 94 amps times this by 3, and I will tell you where the 3 came from, and you're going to end up with 282 amps. The 3, my friends, is coming from table 450.3a. 450.3a, and then you're going to take the 282 amps. Take it to 240.6. What's the next standard, Brad? 300 amp, right? 300 amp. How many fuses? 2 fuses. I have 2 fuses, 300 amp. 2 fuses, 300 amp. Because I have 2 phases, 1 for each. Now I go up here. Why did I go up here, as we said yesterday? The ones who were here, I know a lot of you guys were not here because of the weather, but the ones who are here, guys, we said there's a note number 1 under this table, 450. This is a table, an EC table. If you go to this table, 450.3a, we went yesterday. Under that icon, there's a note number 1. It says if it's not standard, Spencer, what do you do? Go out. So I have a 2 fuses, 300 amp. It gets even worse. Look how the fuses size is going to be different now. 2 fuses are 300 amp. Let's go find the third fuse. So this is the for A and C. B, for B phase, guys, what was the B phase? The primary B phase was the 73. It was 73 amps. Multiply this by the same thing, 3. Multiply 73 by 3, you end up with 219 amps. Take the 219 amps to 240.6, and this will give you the next standard is 225 amp. How many fuses? 1 fuse. And remember, we went up here too. We went up. This is going up. So, my friend, look at that. I have a 300, 2 fuses 300, and 1 fuse 250. 220. Thank you. 225. One of us has to get it. 225. Any question, guys? That's okay. There's nothing wrong with that. Any question, guys, about the primary fuses? Now, what do you, yes, sir?
What is the 3 from?
The 3 is coming from table 450.3a under fuse. Please pay attention. Please pay attention and fuse. I think it gives you fuse and circuit breakers there. So we decided to use fuse. Circuit breaker multiplier under fuse. Now, if I said circuit breaker, Camille, the multiplier will be based on this one, 600. It'll end up with a big boy. On the medium voltage, Spencer, the fuses are commonly used unless you want to spend a lot of money on circuit breakers. Yes, sir.
I'm pretty sure we talked about this yesterday with a project like this, you're assuming that it's the same location, but with a job like this and an actual job looking at from, would this type of building employ probably someone to supervise, you know, or how does that work?
I would say 50-50. But look, if you do that, look at the difference.
250.
The 250. Yeah, because yes, I would say 50-50. If you are smart enough to have a medium voltage control,
Usually with like bus cuts and like all their,
yeah.
they might have their own electrical thing down.
Or they can hire Hunt Electric or Egan to come and do the maintenance for them. Some companies. My philosophy is I always go the worst scenario if I don't know otherwise. Okay, let's go size the secondary, guys. Do you mind going sizing the secondary? Any question about the primary? Okay, let's go number 13. Number 13, my friends. That will be secondary overcurrent protection device, and I decided to use in this case it wouldn't make a difference, guys, had it been a circuit breaker or a fuse. So I'm not going to tell you what I need an overcurrent protection device. So for the secondary, the same thing. We're going to go phase A and C. For phase A and C, the secondary side, guys, for phase A and C is 931 times 1.25 equal, if you times it by 1, equal 1164. And do we have, if you guys look at, yeah, there's note number 1 that tells you to go up, right? is not number 1 that tells you to go up. So I'm going to take 1, 1, 6, 4, take it to 240.6, and have a fuse or a circuit breaker. What's the next standard? 1200 amp. 1200 amp fuse or circuit breaker. How many of them, guys? How many?
2.
2. Why 2? Because the 2 phases. 2 1200 amp fuses or circuit breakers. Doesn't matter if it was a fuse in this case, fuse or circuit breaker. And the calculation is still the same. As long as I'm on it while you guys writing, I'm going to do phase B because it's just repetitive. Phase B. For phase B, my friends, we had phase B we had 723. 723, multiply this by 1.25. If you guys did your math on this one, you're going to find it's 904 amps. Again, we're going to go up. We're going to go up. 904 amp, take it to 240.6, and that will get you a grand, right? 1000 amp. How many? 1 fuse. Why 1 fuse? Because 1 phase or 1 wire.
Okay, that times 125, isn't it?
125 because if you look at the 600 or less, the last column.
Oh, I don't know.
That's all right.
I got it.
You got it? Okay, yeah.
Answer my question. I'm just
Yeah. No big deal. This number I want to bring to your attention, please. These numbers here, this one and this one, as we all know, are coming from 450.3a table. Table 450.3a. And I assume everybody knows why 931, because that's the current that's going through these phases, and why 723, that's the current going through phase B. Now, Camille, my friend, you look at this. You look, one fuse is 1200 amp, the other fuse is 1000. That's okay. Now, here's what's not okay. How are you going to make this a circuit breaker, though? That's why it defeats the purpose saying it's circuit breaker. So this is really, you almost have to go by fuses, because then you have a 600 disconnect fuse, and you put 1200 amp in this and 1000 in this, A, B. So 1200, 1200, 1000. It's the only way you can do it. Can you do it with circuit breakers? You don't. The circuit breakers are either 1000 or 1200. And by the way, if you went at 1200, you exceeded what the code is required for this. On phase B, say I decided now this is, you can't do it. This is, say I decided to go 1200 amp on every phase. You exceeded what the recommendation on phase B would be. I know it's goofy, but the good news is, guys, 99%, well, 95% of the time, all the phases are the same, so you don't get into this situation. Last thing is short circuit. I want to do the short circuit, guys. On short circuit is always on the secondary side. Short circuit. So I'm going to go and based on the short circuit. So find which number are we in? Number 14. 14. Short circuit on secondary side. It's always in the secondary side, but emphasize that one. The short circuit, guys, you find I short circuit equal I. Which I? The worst I. Which I? The worst I. What's the worst I? The worst I is the highest I. So I, because remember there is the I secondary line plus I secondary line for the 3-phase and the single phase. both of them divided by the impedance. Okay, what was the two of them together? Was it 9? What is that?
931.
931. So together 931 amp divided by what was the impedance we said? Did you say 3%? So that will divide this by 0.03. That's your worst scenario, right? That's your worst scenario. I could have done the I3 phase, but that wouldn't be my worst scenario. My worst scenario is what? Anybody came? I don't have this calculation.
31K.
31K and M. 31 kiloamp. 31 kiloamp. So that would be my worst scenario. My worst scenario. Any question, my friends, about these? Warming up before we start the quarter with a couple of calculation. The rest of them, guys, we're going to be doing panels and bus ducts and all this stuff. Because I thought these just warm up with some math with it. Like I did yesterday, guys, at the end of every class, I give you a quick homework identical to what I've done. That's what I do the math. So I'm going to write the homework after my friend, Mr. Urbeb, finish doing his business. Huh? The homework is on the network. So our homework number 2, my friends. Homework number 2. Here's what I have. I have a 12.47 kV / 240 / 120 delta center tab system. Exactly what we did. That's what they call the stuff that we did. Can you guys see the voltage in the primary and the secondary? Okay. Now the sizes that I'm going to use for each transformer. So that's what we get. The sizes for each one of them, guys, as let's go by size. Okay, so sizes are KVA. KVA sizes. I'm going to go by 200, 200, and 300. 200, 200, 300. 200, 200, 300. 200, 200, 300. Everybody knows what the 300 would be? The 300 would be the fat one that's sitting for the neutral, giving the neutral. They always give you guys two the same, one different. Okay, what else do we need to know about this system? We need to know the impedance. Brooks, give me an impedance less than 6. 4. Impedance Z equal 4%, the impedance. Am I missing anything? I gave you the voltage. I gave you the, everything is there, right? Just do the same thing that we did. Are we missing anything? We got, if uses and all the stuff, do your best. Use the same example that we did. So that will give you guys a quick exercise. Do the same thing for this homework number 2. Did we, I'm just trying to see if we missed anything that required here. We gave you the impedance, we gave you the voltage primary, secondary, and Ryan, almost always, the secondary voltage, almost always, the secondary voltage in a system like this is 240/120, almost always. I mean, I've never seen it where it's 480, 240. Because what would you use 480, 240? We don't have receptacles in the US, convenient receptacles that can run at 240. Convenient receptacles, like the one that you plug your laptop in. So that's why it's almost always 240/120. The primary could be different, as we said. The primary, I made the primary different. So 12.47 kV, 240/120. Again, volt. These are volts, no kVs. Center tab delta. This is how we do the center tab delta, guys. Like this, center tab delta system. The impedance is given. Homeworks are due on Mondays, just FYI. I wanted to do a panel today, guys, but I don't want to start something that could take another hour. But that's what we do tomorrow. We're going to take panels now and transformers, size match panels, and so forth.
Are we gonna have to like assignment every day or?
For when I do math, yes. What's wrong with that?
I'm just trying to figure out how many pages.
Are you complaining?
How many pages and you can have a state law.
Yes, for the most part, yeah.
So you think we're
Yes,
around
yes.
25 of them?
I would be probably 25, yeah. About 20, 25 assignments. All of them, guys, are straightforward. Yeah, sorry, Brad.
Oh, I thought you said something important.
All of them are straightforward. Any question, my friends? Okay, just a quick reminder. Let me zap my